Okay, this video has to do with the notes that we took about limits in class. And the notes can be found online on my teacher site. All right. So I discussed in class that to find the limit, and this is the notation, the way that it works is you simply take the little number that's right below the letters limit. You take that, it says X, little arrow, and a 1 there. The way it works is you take the 1 and you plug it in. And so let's see what we get. In this case, we get 1 to the 4th minus 1 cubed plus 1 all over 1 squared plus 9. Let's simplify that. Well, the 1's cancel out here, so you just have 1 in the numerator. In the bottom, we have 1 squared is 1 plus 9, 10. And so the answer is 1 over 10. Okay, so that's basically what you do to find the limit. Now, occasionally, there's a problem. Like, for example, 14 here. So the problem is that sometimes when you plug in the 2, or whatever value is here, you get 0 in the denominator. And as we know, we can't ever have any number divided by 0. But that's what we get in example 14, or problem 14. Take the 2 squared is 2, 2 minus 4 is 0. So that's a problem. Now, before we say that this problem is no solution, in class I discussed that there's a trick that sometimes can work. And the trick is to factor the expressions out and see if anything cancels out. So let me show you. Cancel the factor the numerator, we get these 2 parentheses. We factor the denominator, we get these 2 parentheses, and we can see that these cancel out, x minus 2, top and bottom, giving me this simpler expression. And at this point, if we go back to what we were trying to do originally, that is plug in the little 2 into the x's, if we do that now, and so we're not going to plug in 0, we're going to plug in 2. Let me erase that. So we get 2 minus 1, and then 2 plus 2. So that should be a 2 there. Okay, so then the answer is going to be 2 take away 1 is equal to 1, and 2 plus 2 is 4. So this is my answer. The limit as x goes to 2 is 1/4. So even though at the start we had a problem, this trick, as I said, sometimes helps out. And so that is the answer, 1/4. Okay, now another kind of difficult problem is when we have square roots. For example, number 20, I did this one in class, number 20. We have a square root there. Okay, and if we plug in 2, we get 0 in the bottom as well. So we have two problems here. 0 in the denominator is by far the biggest problem. But then this radical also can cause the problem to be a little bit more difficult. And so what we went over in class was to multiply the expression, the original problem, by the conjugate. This binomial here, the conjugate, we did that in class, was to take that same expression but change the sign in the middle. So that minus becomes a plus, and we have to multiply top and bottom so that we don't change the original problem. And then because it's a binomial, we FOIL. Now, there's a benefit of having a minus and a plus, and the benefit is that when you FOIL, the outer and the inner those terms cancel out. So we simply get 4 times 4 is 16, and then minus the square root times the square root. The square root just cancels out because it's we're multiplying the same square root. So we have 18 minus x. Okay, if I distribute the negative and then simplify the numerator, I get x minus 2 in the numerator, which will actually be, it'll cancel out with the bottom x minus 2, which is nice. It gives me a simpler answer. And at this point, when we plug in the 2 into x, we no longer get a denominator equal to 0. We get 1 over 4 plus the square root of 16, which the square root of 16 is 4. And so 1 divided by 4 plus 4 is 1/8, and this is my answer. Now, the other kind of problem that I talked about in class were limits that instead of a little number on the bottom, we had an infinity on the under the limit. And for those, I presented that we have 3 cases for the limits that go to infinity. 3 cases. And the difference between the cases has to do with the exponents, how they compare in the numerator and denominator. So case number 1 is when you have polynomials with the same degree. And so the degree is the same, the exponent is the same, top and bottom, and the answer automatically it will be a over b. The limit is equal to a over b, the coefficients. Case number 2 is when the denominator or the exponent in the denominator is bigger. Automatically, the limit is 0. And finally, case number 3, when the denominator or the numerator has the bigger exponent, then the limit does not exist. And here I think I was making a reference to the movie Mean Girls, which was a joke there. Okay? But anyways, so let me show you. Okay, so problem number 5. Let's talk about problem number 5. If you look at the exponents, it's 1 and 1, so it's the same exponent. So then we are in case number 1. Case number 1, same exponent. The limit is simply a over b. So in this case, the answer is going to be limit 2 over 5, a over b. Okay. Problem 6. The exponent on the in the numerator is bigger, so that would be case number 3, and the limit does not exist. So problem 6, exponent is bigger, so automatically limit does not exist. And finally, case number 3, when the exponent in the denominator is bigger, automatically limit is equal to 0. And that is it.